am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is Bridge Rectifier. So, recalling about the diode is a semiconducting which allowing current and flow in one direction, forward bias condition and reverse biasing condition. So, pulsating DC, both cycles utilized. So, these are all the things which we are discussed about semiconductors. So, in rectification, diode plays a major role. So, DC and why do devices need DC and not AC? The core problem, wasting half the power. Two smart solution emerge. What are all the practical applications of the half wave rectifier? So, rectifier is a device which is used to convert the DC, pulsating DC to an alternating signal, so AC signal. So, why do we need DC? So, for basic applications like charging your smartphones, charging your laptops, a charger is a storage capacity which requires a DC supply to charge the battery. So that we need a DC supply so that we can able to charge our mobile phones. So battery drains fast in DC devices. Output is not that smooth, which is compared to an AC signal. Ripple is high factor. So rectifier is further classified into two types, half wave rectifier and full wave rectifier. The core problem of these half wave rectifier is it wastes the half of the signal power. So half wave wastes 50% of AC cycle, high ripple factor, poor efficiency and heating. Not suitable for high power devices. So it is used for both positive and negative half cycles of AC. So bridge rectifier, full wave rectifier is a positive half cycle and negative half cycle. It plays a role both in positive and negative half cycles. In positive half cycle, it conducts in D1 and D2. In negative half cycle, it conducts in D3 and D4. So full wave rectifier wave is a full AC signal wave. We got the output. So waveform and parameters are rectification efficiency is about 81.2%. Peak inverse voltage is central tapped to be compared it as 2 voltage meter. Bridge rectifier VM maximum voltage. So average DC output voltage 2 VM bar pi. So output ripple frequency is twice the input frequency. So 100 Hz to 50 Hz supply. So practical applications, we are using it in a mobile charger, UPS, DC, AC inverter. So talking about UPS, it is used for supply the current while the power supply is cut off. So it stores the energy in the form of battery. So for charging the battery, we need the AC supply. So LED drives, we are using the DC supply, solar charger controller, audio amplifier power supplies, welding machines, inverters and UPS, LED drives and mobile laptop chargers, we are using the DC supplies. So recalling about the topics and the content are given in this summary form. So these are all the reference which we can refer the half wave and full wave rectifier. So talking about this waveform, so AC input alternating signal is given in an circuit, whereas D1 current is half the value of 0 to pi value, whereas in another half cycle it does not conduct any current, it lies on the 0 and then it starts conducts in the D1 current and then in a negative waveform. So whereas in the next input, it delays the current by 0 to pi value and then it starts conducts in the positive cycle and then it applies on a 0 and then it conducts in a negative half cycle. So comparing these input to the applied D1 and D2 area, which we can gain a full cycle, whereas the efficiency and losses of half wave rectifier is completely neglected, so that we can get a positive and negative half cycle in a bridge rectifier. So talking about this circuit, we are having a 4 diode connected in series to each other. So this arm like structure of connecting the LED is known as bridge rectifier. whereas we are naming that as D1, D2, D3, D4. It is connected across a AC supply, where we are connecting across the D4 and D3 across the load current. Output is gained across the D4 diode. So diode bridges is connective across positive and negative half cycle, whereas positively D1 and D2 and negative half cycle is D3 and D4. So this is the basic construction and working of an bridge rectifier. Thank you.